Hello, I welcome all. Now in previous lecture we have seen the basic introduction towards the retaining wall, its types and conditions when retaining wall is to be provided. Now today we will be seeing various cases of the backfill in which retaining walls are to be designed. Now very first terminology you must know, that is active earth pressure and passive earth pressure. Active earth pressure and passive earth pressure. Now in geotechnical engineering or say soil mechanics, you might have learned these terms, active earth pressure and passive earth pressure. Now earth pressure which tries to move the retaining wall away from the backfill, that is nothing but active earth pressure. The earth pressure which tries to move the retaining wall away from the backfill is nothing but active earth pressure. Now let us consider this example. This is the T-shaped retaining wall. T-shaped retaining wall. This is toe, heel and stem. Now if backfill is provided, here backfill is provided, then active earth pressure will be acting on the side of backfill. Active earth pressure will be acting on the side of backfill. That is nothing but active earth pressure PA. And this will tend to move the retaining wall, or deflect the retaining wall in this manner. It will tend to deflect or move the retaining wall in this manner, that is move away from its original position, hence called as active earth pressure. And second terminology is passive earth pressure. Now passive earth pressure is nothing but earth pressure acting from the opposite side of backfill. Passive earth pressure is nothing but pressure acting from the opposite side of the backfill, and it will tend to maintain the position of the retaining wall. Active earth pressure is nothing but pressure acting from the direction of the backfill, tending to move the retaining wall from its original position, and passive earth pressure is nothing but earth pressure in opposite direction of active earth pressure, that is, or you can say passive earth pressure is nothing but pressure acting in opposite direction from opposite direction of the backfill. This is nothing but passive earth pressure PP. This is nothing but active earth pressure PA. Now let us have towards the look towards formulas. Now active earth pressure coefficient Ka, active earth pressure coefficient Ka will be calculated by the formula 1 minus sin phi divided by 1 plus sin phi, where phi is angle of internal friction. This equation you might have learned or gone through in the subject geotechnical engineering or say soil mechanics. Active earth pressure coefficient Ka will be determined by Ka is equal to 1 minus sin phi divided by 1 plus sin phi, where phi is nothing but angle of internal friction. Now we will move towards various cases of the backfills, which cases may occur so as to design the retaining wall. Let us move. Now this is the very first case, retaining wall with dry backfill without surcharge. This is the retaining wall, this is the retaining wall, and this is the dry soil. And retaining wall with dry backfill without surcharge means no extra loading is provided over the plane surface of the backfill. This is the first case. This is the pressure diagram for the same. This pressure diagram also you might have studied. This is the pressure diagram. As depth of the backfill goes on increasing, the pressure intensity will go on increasing. Hence, at the base, the pressure will be Ka into gamma into H. Ka is nothing but active earth coefficient determined by the equation 1 minus sin phi divided by 1 plus sin phi, where phi is internal angle of friction. And this B is nothing but base width. It can be calculated by K into gamma into H. Active earth pressure, gamma is nothing but unit weight of soil, and H is nothing but total height of the retaining wall. And here PA will be acting, that is nothing but active earth pressure. Now as this pressure diagram is triangular in nature, then force will be half into base into height. Half into base into height, base is nothing but B, height is nothing but H. Now here B base we can substitute as Ka into gamma into H. Here you can see half base is substituted as Ka into gamma into H, and H is nothing but height of the retaining wall. Hence active earth pressure PA can be calculated by equation half Ka into gamma into h square. Pa is equal to half Ka into gamma into h square. Now this active earth pressure Pa is acting at a distance of h by 3 from the base. H by 3 from the base. In short, you might be knowing, if triangular area loading is acting, then it is acting at an h by 3 distance from the base. These CG formulas you might be knowing. In this way, when retaining wall with dry backfill without surcharge is there, you are supposed to use this equation. Pa is equal to half Ka into gamma into h square. Ka active earth pressure coefficient, gamma is unit weight of soil, and h is the height of the retaining wall. And this force will be acting at height of h by 3 from the base. Now let us move towards case number 2. Now this is the case number 2 when backfill is submerged. This is the case number is 2 where backfill is submerged. Now when backfill is submerged, active earth coefficient will be 1 for water, since internal angle of friction will be 0. For submerged soil, active earth pressure coefficient Ka is equal to 1, because for water internal angle of friction, that is phi, will be 0. Now how this value has came Ka equal to 1? You might be knowing Ka is calculated as 1 plus sin phi divided by 1 minus sin phi. Now since internal angle friction coefficient phi is 0, sin phi, substitute phi here 0, sin 0 will be 0, sin 0 will be 0, hence 1 by 1 we will get Ka equal to 1. Ka equal to, sorry, here it is 1 minus sin phi and here it is 1 plus sin phi. We can calculate active earth pressure coefficient as Ka equal to 1 minus sin phi divided by 1 plus sin phi. Substitute phi equal to 0, since soil is submerged, we get Ka equal to 1. Now if soil is submerged, there will be pressure diagram due to two conditions, that is Ka into gamma submerged into H, and this width will be gamma W into H, that will be water effect. Hence this pressure diagram you should consider, where two components will be there. First one will be, base will be Ka into gamma submerged into H, and second will be gamma W into H. Now gamma submerged will be nothing but unit weight of submerged soil, and gamma W will be nothing but unit weight of water. H is nothing but height, K is nothing but active earth pressure, and Pa is nothing but earth pressure, active earth pressure acting from the side of backfill at a distance of h by 3 from the base. Now here B is total base will be Ka into gamma submerged into H plus gamma W into H. Then we can determine Pa as half base into I, since triangular loading, half Ka gamma submerged into H plus gamma W into H into H. Now gamma submerged can be calculated as gamma saturated minus gamma W, and gamma saturated can be calculated by formula or equation gamma W into bracket G minus 1 divided by 1 plus E. Gamma submerged can be calculated as gamma saturated minus gamma W, whereas gamma saturated can be calculated as gamma W into bracket G minus 1 divided by 1 plus E. Now all these equation and terminologies you can go through the soil mechanics or geotechnical engineering, so that your concept will get cleared. Now let us move towards the third case. Now this is the third case where partly submerged backfill is provided, or where backfill is nothing but partly submerged backfill. This will be the case where submerged soil is available up to height of H2, and for height of H1 dry soil is available, that is nothing but partly submerged backfill. This will be the pressure diagram for the same when partly submerged backfill is provided. First, second, third and fourth total pressure diagram will be divided into 4 components, whereas this base will be Ka gamma D into H1, where gamma D is nothing but unit weight of dry soil. This component will be, third component base will be Ka into gamma submerged into H2, unit weight of submerged soil, and this fourth component will be gamma W into H2, that is unit weight of water gamma W into H2. This base for the first and second component will be Ka into gamma D into H1, where gamma D is nothing but unit weight of dry soil, H1 is nothing but depth up to which dry soil is filled or available, and H2 is nothing but depth up to which submerged soil is available. And this third component base will be Ga into gamma submerged into S2, unit weight of submerged soil, that will be gamma submerged, and fourth component base will be gamma W into S2, where gamma W is nothing but unit weight of water, and Pa will be acting in this direction. Now Pa will be acting at an X bar, as this is triangular pressure diagram and which is distributed into 4 components. Hence we will calculate Pa as addition of all these 4 forces acting due to this all 4 components. Now say this is first component 1, then it will be half base into height, that will be half Ka into gamma d into H1, Ka into gamma d into H1 into height H1, plus area of second component Ka into gamma d into H1 into H2, area of third component Ka into gamma submerged into S2, that is half Ka into gamma submerged into S2 into H2 height, since it is triangular, and area of this half base into height Ka into gamma W into H2 into S2, Ka into gamma W into H2 into S2. In this manner you are supposed to determine the active earth pressure Pa when partly submerged backfill is available, that is submerged backfill, and remaining portion will be of dry backfill. You must remember all these cases. Now let us move towards the case number 4. Case number 4, backfill with uniform surcharge. Case number 4, backfill with the uniform surcharge, means where backfill is provided and UDL surcharge is provided. If the backfill is horizontal and carries surcharge of uniform intensity W unit per area, the vertical pressure increment at any depth H will increase by W, that will be nothing but unit weight of UDL. The increase in lateral pressure will be Ka into W. K is nothing but active earth pressure and W is nothing but intensity. Now consider this stress diagram. This is the pressure diagram. This is the retaining wall backfill subjected to UDL or say surcharge, that is uniform. Hence this intensity is called as Q. It will be kilonewton per meter square or say W. And this is the pressure diagram. Now pressure diagram here will be due to 2 conditions, that is due to backfill and another will be due to surcharge. Then this will be the nature of the pressure diagram, where base of the first component will be Ka into gamma into He, and base of the second component will be Ka into gamma into H. First component base will be Ka into gamma into He, and second component base will be Ka into gamma into H. Now what here is He? He is nothing but extra height which is due to surcharge, and this He can be calculated by formula He is equal to Q by gamma. Q is nothing but unit intensity of the backfill, that is unit intensity of the surcharge over the backfill. This is nothing but Q, and gamma is nothing but unit weight of soil. Hence He will be ratio of unit weight of intensity of the surcharge to the unit weight of soil, and this He will be the height of this component. Hence here He, and base at here will be Ka into gamma into He. H is nothing but this height calculated by this equation. H is equal to Q by gamma. Q is nothing but unit intensity of the surcharge acting, and gamma is nothing but unit weight of soil. Hence this base will be total of Ka into gamma into He plus Ka into gamma into H. In short, it will be Ka into gamma into bracket He plus H, where H is nothing but Q by gamma and capital H is nothing but height of the retaining wall. Now here in all 2 pressures will be acting, and resultant of that will be Pa. Now first pressure will be P1 due to this triangular component, and second pressure will be P2 due to this rectangular component. This P2 pressure will be due to this rectangular component and P1 will be due to this triangular component, and this P1 will be acting at half Ka into gamma into H, half Ka into gamma into H into height H at an distance of H by 3. At an distance of H by 3. Here you can see P1 is acting at an distance of H by 3 and P2 is nothing but area of this rectangular portion Ka into gamma into He into H, total height H. Hence P2 is Ka gamma He into H acting at H by 2. Acting at H by 2. In this way, when backfill with uniform surcharge is provided, you are supposed to consider this diagram and this pressure diagram so as to calculate the active earth pressure. Now we'll move towards the case number 5. We'll move towards case number 5, and case number 5 is backfill with sloping surcharge. In previous lecture we have seen what do you mean by surcharge and surcharge angle beta. Case number 5 is backfill with sloping surcharge, that is beta, where backfill is at an angle beta with respect to horizontal, and this will be the pressure diagram when backfill is provided with the sloping surcharge, where base here will be Ka into gamma into H. Base here will be Ka into gamma into H. H is nothing but height of the retaining wall, and Pa will be acting parallel to this base. Pa will be acting parallel to this base, or say at an inclination of beta angle with respect to horizontal, or Pa will be acting parallel to the sloping nature of the backfill, or you can say Pa is acting at an angle of beta with respect to horizontal, and Ka here can be calculated by the equation cos beta into bracket cos beta minus under root cos square beta minus cos square phi divided by cos beta plus under root cos square beta minus cos square phi. With this equation, we are supposed to determine the active earth pressure coefficient Ka when backfill is provided with sloping surcharge. In this case, you are supposed to determine active earth coefficient as cos beta into bracket cos beta minus under root cos square beta minus cos square phi divided by cos beta plus under root cos square beta minus cos square phi. Now, total active pressure Pa for the wall height H is calculated as Pa is equal to half Ka into gamma into H. Since it is triangular pressure diagram, hence formula will be half base into height, where base is Ka gamma into H and height is total height H. Hence we can write Pa is equal to half Ka into gamma into H will become H square, acting at H by 3 from the base. Acting at H by 3 from the base. Now these were the 5 cases that we have seen. Now let us move towards the passive earth pressure Pp. Passive earth pressure Pp. Now Pp is nothing but Kp into gamma into H. Kp is nothing but coefficient due to passive earth pressure, that is Kp. It is calculated by the formula 1 plus sin phi divided by 1 minus sin phi, or you can say reciprocal of 1 by Ka. Equation for K is 1 minus sin phi divided by 1 plus sin phi, whereas equation for Kp is 1 plus sin phi divided by 1 minus sin phi, or you can take reciprocal of Ka, where Kp is coefficient of passive earth pressure. Now consider this case. This is the retaining wall, this is the pressure diagram due to backfill, and this will be the pressure diagram due to backfill or say soil on the opposite of the retaining wall, hence called as passive pressure. And this passive pressure will be due to height H up to which soil is available on the opposite side of retaining wall. This will be the pressure diagram Kp into gamma into H. Kp is nothing but passive earth pressure coefficient, gamma unit weight of soil, H is nothing but height H up to which this soil is available on the opposite direction. Hence Pp, passive earth pressure, will be calculated by the formula half base into height, since triangular pressure diagram, half base Kp into gamma into H into height H, that will become H square, acting at H by 3 from the base. Acting at H by 3 from the base. And this note is to be kept in mind that during calculations for Pa, the Pp due to other side of wall is generally neglected because value coming of this Pp is very small. Generally neglected since it is possible that this soil is very less or will get eroded by the passage of time. Or if any soil is available, this Pp value will be very less as compared to Pa, hence generally it is neglected during the calculations. Now in this way we have seen these 5 cases of the backfill. First one, retaining wall with dry backfill without surcharge. Second case, backfill is submerged. Third case, partly submerged backfill. Fourth case, backfill with uniform surcharge. And fifth case, backfill with sloping surcharge. You are supposed to remember all these 5 cases of the backfill so as to design the retaining wall depending upon the site conditions. For any doubts, comment in the comment box or go through the notes, and link for the notes is provided in the description box. Thank you very much.